Hello students, I'm Dr. Kapil Chaturvedi and today we'll discuss our topic of software engineering, that is software design and software design process. So in this lecture, we will cover following topics: software design, objectives of software design concept, different levels of software design, and at last we'll discuss principles of software design. So we know very well that the software design is a most important and essential thing during the whole process of software development, because that is the basic infrastructure. This one is the prototype which will decide what will be the flow of the project, what kind of users will use that, and what will be the duration of assigned to the particular module of the project, and different kind of things like database design and many more things you will decide and design before coding phase. So but by performing this kind of task, by performing the designing, you must keep in mind many of the things. So let's try to understand what is design, then we'll go on the different concept and principles of the design. So software design is the process of transform the user's requirements into some suitable form, which helps the programmer in software coding and implementation during the software design phase. The design document is produced based on the customer's requirements. As document in the SRS, it means software requirement specification document. Hence, the aim of this phase is to transform the SRS document into the design document. So as we discussed, basically the design is basically will be 100% or purely depend on the SRS. It means software requirements specification provided by the customer. So following items are designed and document during the design phase. Different modules required. What kind of module we require? What kind of relation will be in different modules? Interface among different modules, data structures like data flow diagram and DR diagrams, algorithms required to implement among the individual modules, what kind of concept you are using, what will be the flow of the project. Basically, we'll adopt the flow chart to represent algorithm or process of the project. If we discuss on the objective of software design, so there we have some objectives of designing phase. First is correctness. Basically, if we have a design, if we have a blueprint, then the implemented software will be correct. Efficiency will is also a next part of efficiency is another part of the software, because if software is not efficient, no one will use that. So if you have to develop an efficient software, you must create a design. Understandability. Let's suppose if a new developer will work on a previous developed project, then to understand that project, and that particular developer will uh, study on the designs, different designs, so that he or she can easily understand what is the flow of the project, what kind of relationship established in different databases, what kind of users will use what kind of pages. So by seeing that design documents, different designs, different blueprints, developer can easily understand. Completeness is another part where you can complete the project while following different blueprints. Maintainability is also is the another part uh, uh, of the software. Maintainability, it means a software should always capable to modify in future. If let's suppose a customer want to modify, customer want to add on some more features in the software, and a new developer is work on a software which is already developed. So to understand that project, that will first go on the design, check the blueprint, check the flow, check the relationships, and will modify that software. But that thing is possible because of only design. If we have not designed, then we cannot modify a 10,000 of lines code easily. Now, now we are coming on the software design concepts. There are different design concepts. We have abstraction, uh, refactoring, information hiding, pattern, refinement, architecture, and modularity. So abstraction, you know very well that abstraction is a concept of object-oriented programming, where we see that we are hiding the abstract of the code and provide the needful information. So that is the basic concept of coding. We have to hide the basic logic, internal logics of the coding, and provide the needed terminologies, things. Refactoring, it means the future of modification, possibility of modification in future. Information hiding, again, information hiding, it means the logics will always be hide from the end user to prevent the code from hacking uh, like things. Uh, Pattern and refinement, it means um, once we develop a software, we we check code again and again to optimize that, so that the code should be refined. Architecture, it means the code or your whole software uh, should be in a well mannered architecture. In if we have to arrange whole software, we have to understand that whole software, then we can easily understand by drawing a proper architectural view. If we are working on school management software, then we can divide that in examination, academic, account section, student section, employee section. So that there is a hierarchy. That is a hierarchy, and then these are the different modules of the software. So if we mass up these all things in common coding, then you cannot understand that code, and you cannot modify that code in future. So that should always be in architecture form. Modularity, it means again the same thing, but here we divide our project in different modules. Like we uh, first module is login module, second module is report module, third module is student information module, fourth module is account section module, next module is examination module. So that kind of modules may available in the software. So first we divide a software in different modules. So that these are the software design concept which we have to adopt, which we should be adopt, or which we will adopt in software development process. Now the different level of software design, if we discuss on the different levels of the software design, we can see that client demand. When we have to start a software development, first we contact to the customer and we try to understand what is the demand of the client. Now, acceptance testing is a parallel phase here, because we have to check that if that particular expectation is feasible or not. So we have to check whether that possible is not or not. Requirement gathering. First, we understand the demand of the customer. We analyze the different things and gather the information, related information. Then we design. It means in this phase we will develop ER, DFG, Gantt chart, flow chart, different kind of diagrams we will make, and also we will decide what kind of and which module we will use to develop that software, like waterfall model, component-based software development model, spiral model, prototyping model. Many kind of models are available. Hundred of models are available. So we have to decide what kind of model we have to adopt. So we'll decide in design phase, and then we will go on the coding phase, and we'll implement the actual thing by making the code. Then we perform the testing. Unit testing, it means we will perform the testing on different modules. Then we will integrate all the units and we perform the integration testing. System testing, it means whole testing along with your system and hardware related and also the network related issues will test all the things is going okay or not. And acceptance testing again, it means here we are talking about the client side testing. We deploy the software on the client side and we test uh, and customer will use the demo version of that and will provide the suggestion to us and will further we modify the code as per the requirement of the customer and again provide and again deploy that code to the client side. So this is all the different levels of the software design. Now, the last thing is principles of software design. What kind of principles we should adopt in designing? So, if we consider that our software is a plant, a tree, and here we have different branches, and these branches are principles. So, the principles are programming paradigm, uniform, and integrated. So, if we are making the code, so you must have to follow a uniformity. That there should be a uniformity in coding. Cannot make different kind of random paradigms. You cannot adopt different kind of paradigms in coding. Integrate gently, code reuse, and prototyping. It means the code should be reusable. Or here another thing is that you should use the code which is already used in another module. You can retest that and you can use. Prototyping, it means the cycle will continuously go on of the modification from the client side. So that should be in that feature should be in your software so that um, we can easily modify that software in future. Represent correspondence between software and real world problem. This is the major thing. If you are making a software, you are developing a software and that software is not matching with the real time scenario, then no one can adopt that. So that's the mandatory thing where your software should be on follow the real time features, real time procedures, and the real time mechanism. You can adopt, you can use some of the additional features in your software, but you must follow the real time procedure, real time paradigm. You have to convert the manual process into software process by adopting the real time, real world system. You cannot make your own system. Let's consider an example of banking. You can if you're converting the manual banking into the online banking, computerized banking, then you cannot provide your own procedure to for banking. You have to follow the same procedure of manual processing. Huh? Yes, you can make some additional features in this of verification, security, login, many more. But you have to follow. First of all, customer have to open an account. Then a customer can deposit the amount. Then he can withdraw the amount. That this is the banking procedure. This is the banking procedure. If you have to demanding for the loan, you must have to provide your basic information. You have to fill a form and submit to the bank, and the bank will decide you are eligible or not for that loan. Some procedure will be adopted by the online system, where online system will make the entries in online form and will check by EI based system you are eligible or not, what amounts should be released to you as a loan. So that mechanism will be same, the procedure will be same, the flow will be same in both of the cases. So that thing is the represent correspondence between software and real world problem. Ensure minimal conceptual semantic errors. Yes, this is the thing which we have to keep in mind. There should be minimum errors. We cannot make the software with error free, exception free. Even in the Microsoft's product, Word, Excel, and PowerPoint, you see many of the times it show the message an unexpected error occurred. You want to send that error to the Microsoft. It means Word, the product of the Microsoft, and we are here. What we are seeing, there is an exception. There is an exception. It means no software can error free. No software error. It means exception. No software can exception free. But we must have to keep in mind that the chances of that kind of exception will be minimum. Correspondent to analysis model. Correspond to analysis model. So these all are the principles to make flexible your software. You must have to keep in mind these all the principles during the development of software. So this is the lecture which is explaining you why we adopt the design, what is the need of the design, and why we mandatorily adopt the design, and what kind of things which we have to keep in mind during the design. Okay, so thank you.